Assalamu alaikum. This is Hassan Rez from Group 8, and our project is on about the characteristics in vibration. So introduction, in the introduction we can say that our object is to find the good solution for the isolator pad. Here we can see the problems. Okay, case study. The case study is of this project that we have to find the characteristics of the vibration. So in the characteristics we can get the assessment of natural frequency, mode shape, isolation zone, which are important in order to understand the problem in the exist in the isolator pad, and we have to recommend a good solution for this. And here we can see the parameters for our solution. So from here we have to find a better solution. Methodology is very important in computational mathematics. An iterative method is a mathematical procedure that uses an initial guess to generate a sequence improving approximate solution so that we can get proper solution. So for this we are getting the general equation of motion, and then after that we have to derive the equation of motion F equals to ma. So after derivation we get it in the matrix form. Then we have to calculate it via the harmonic equation. So here we can get a harmonic equation. After that we have two possible solutions. One is lowest natural frequency and another one is highest natural frequency. Through this way we can do the calculation. In the validation method, for the validation method, eigenvalue is very important. Eigenvector we use in eigenvector. So for the natural frequency, omega n equals to 1 over root over lambda, and lambda is here eigenvalue, and the highest natural frequency is root over lambda. So eigenvalue and eigenvector calculator. So what is eigenvalue? In linear algebra, an eigenvalue or characteristic vector of a linear transformation is a non-zero vector that changes by a scalar factor when that linear transformation is applied to it the corresponding in eigenvalue. Eigenvalue is often denoted by the factor by which the eigenvector is scaled. So here we will use this process, and we can see that the k2 plus k1 over m1 minus k2 over m2, k2 by m2. We will use this formula to make our solution. So here this is our problem, and for our problem k1 is 150 newton per mm, k2 is 600 newton per mm. So after that we did the formula, then we are applying this. So lambda 1 and lambda, this is identity matrix, then we have to minus it, then we got the solution. After this we get lambda square minus this one equals 0. After that after solving this equation we get omega n square equals to 955.98. that is eigenvalue, and the omega n, that means natural frequency, is 30.91. mode shape is this one. And for the highest value, this omega n square equals to 17453.34, and omega n equals to 132.11. For the second design, following previous step, we did the calculation for the second design as well, but in here we use k1 and k2 as the same value, and which is 600 newton per mm. So here after getting the formula we get this, then we use the, and then we calculate this via this step, and after that we get omega n square equals to this value, and our eigenvalue is 3354.97, and natural frequency is 57.92. And for the second one, for the highest value 19893 from this one, and 14104 radian per second, and mode shape is minus 0.927. So after that we got the result and mode shape for design 1 and design 2 as well. Then validation method. For the validation method, it's very important, is it our result good, proper or not. So we did the validation in the calculator. So for this thing, at first we have to go to eMath, and I give you the link here. Then the second step is to we have to input the values in the matrix form. So I input the values here. Then we have to find the eigenvalues in eigenvectors. Then we can enjoy the solution, get the solution. So afterwards, after all this solution, finally we get the answer. The eigenvalue is 955.98, mode shape is 0.907, and highest eigenvalue is 1753.34. So we can compare that with our result. This is less different from the our calculated result in the eigenvalue calculator, and that's all. So this is our project finally finished. Assalamu alaikum.